Question 3, June 2021, and it says the diagram below shows the triangle PQR in which QPR is 62 degrees, so this is our 62, and angle PQR is 90 degrees, and we can see this little square right here which represents our 90 degrees. And PR, which is our hypotenuse, is 11 centimeter. And part 1, they ask us to calculate the angle of PRQ. This is a really easy calculation, if I might say. So can anyone tell me what angle PRQ is without me stating it? Angle PRQ, very good, Taki, is 28 degrees. Did they say state the reason? No, they did not. But what is the reason? I'm waiting for someone to tell me the reason. Because angles in a triangle.
Interior angles in a triangle equal to 180 degrees. Very
good. So that is the reasoning that we use in arriving at our answer. Angles in a triangle add up to 100. So the interior angles within a triangle add up to 180 degrees. So there are 3 sides to the triangle, 3 angles within the triangle. If we're given 2, then we can easily find out what the unknown is. And all we need to do is to add the 2 known angles, which in this case is 90 and 62, and subtract it from 180 degrees. So what we'll have is 180 degrees minus 152, and therefore angle PRQ is equal to 28 degrees. And the reasoning, more than likely, sometimes they usually ask you for the reasoning, is because sum of interior angles in a triangle is 180 degrees. So that is the reasoning as to how we solve this question. So total angle in a triangle adds up to 180. So there are 3 sides in the triangle. We know 2 out of the 3. So we just add the 2 that we know, which is 90 and the 62, subtracted from 180 degrees, and we got the unknown, which is 28 degrees. Part 2, it asks us to calculate the length of RQ. So we're looking at the length of RQ. What are we using here? Which mathematical concept? Anybody? Which mathematical concept can we use here to solve trigger? So trigonometry, which Shanisa said, sine rule, no, not the sine rule. Pythagoras Theorem. Can somebody tell me why we can't use Pythagoras Theorem here, please?
We don't have 2 sides.
Very good. We don't have 2 sides. So you use Pythagoras Theorem when you have 2 known sides. In this case, we only have 1 known side, so we cannot use Pythagoras Theorem. So we'll use trigonometry, and we are using sine. So Janelle is asking a question. Go ahead. Or she put on her hand? Okay. So that is it. So what we'll use is sine. So we'll use sine theta. Where's my theta sign? Sine theta is equal to, and we know it as opposite over hypotenuse. What is our theta? What is our angle in this case? Anybody? Sine 62. Why Kyle gone left way. So we're looking at 62 degrees. RQ is opposite to 62 degrees. So therefore, what we're basically trying to find here is the opposite side in this or equation, which is our RQ. and that is divided by our hypotenuse, we can easily identify our hypotenuse, which is 11, usually the longest side on your triangle. So now solving for RQ, the 11 is dividing here, so we're basically multiplying both sides of our equation by 11. So what we'll get is sine 62 multiply by 11, and that will give us RQ. And therefore, when you work that out, very good, you will get 9.7 or more exact. What I got is 9.71 centimeter is equal to RQ. If we're writing it to two significant figures, it would be 9.7. So that is our answer for the length of RQ. Yes, this webinar is being recorded. It will be on YouTube, and the name of the YouTube channel is to be on the top of the page, which is prepared for it. You will see it shortly. Any question from this finding the length of RQ? So that is how we work that one. So those were easy questions. YouTube channel. So now we're at part B, and it says the diagram below shows triangle X, Y, and Z. This was probably the next difficulty that children went into, and we're now basically on page 10 of this exam sheet. Let me see how many pages are there. 31, 33. We're now on page 10. It says 3 triangles X, Y, and Z on a square grid below. So on our little graph paper, fun. And it says if triangle X is mapped onto triangle Y, so this is triangle X right here. So triangle X, which is right here, they're saying that triangle X is mapped onto triangle Y by a reflection. So they told you what exactly is happening. They want us to state the mirror line. And we looked at mirror line before, and we stated that the mirror line is the halfway mark between both images, or the object and the image rather. So looking at X and Y, where is this reflection taking place? And remember, you're writing it in the form of an equation. Very good. It is taking place at the point Y is equal to 0, which is right here. So our equation would be Y is equal to 0. So at the point Y is equal to 0, and you might be wondering, how did we get that? If, let's say, we're using these points. So this point and this point, we're going to do that. So we're looking at the halfway mark between these, and you can use any point, by the way. So from this, we're moving 1, 2, 3, 4 units. So 4 units separate those points. So you're basically looking at the halfway mark. So a half of 4 is 2. So therefore, the mirror line would be at 1, 2. So this would be where the mirror line is. And at this point, Y is equal to 0. So remember, because this is our x-axis, and all along our x-axis, Y is equal to 0 at every point on our x-axis. You could use, if you're using these points on the triangle, the distance between these is 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 7 units, 8 units. So those 2 points are 8 units apart. If you divide 8 by 2, then you will get 4, which means that the mirror line is 4 units away from each point. So it would be 1, 2, 3, 4. So we still end up at this point, which is where Y is equal to 0. So at any point on your triangle, should you choose you will always end up at the point y being equal to 0 being the mirror line, which is that line which is halfway between both the object and the image. Any better, Kyle? All right. Let us see if we can use. So in previous classes, I think last week or the week before, we looked at questions similar to reflection. So basically, let's now use this point that we haven't used as yet. What reflection basically is looking at is, if you are standing and looking in a mirror, however far you are from the mirror, it will be how far it seems as if you are within it. So whatever that is in between you in the mirror, all of those objects will be showing in the reflection, which is in the mirror. So you're looking for what is that line which is halfway between the object and the image. So for example, if let's say this was our object is right here, and my image is right here. Comparing these 2 points, what would be my mirror line? Anybody comparing these 2 points, what would be my mirror line? Thank you, Selena. Y is equal to 1. No, I think it is 1. Because look, remember, between these 2 points, you're moving from this to this. So you're 1 unit, 2 units, 3 units, 4 units apart. So you're looking for the halfway mark between this. So it would be 4 divided by 2. So our mirror line, it's basically halfway between these 2 points. It would be 1, 2. So this would be where my mirror line is. At this point, y is equal to 1. So this would be where my mirror line is. It is that halfway, the middle point, that line which is in equal distance from both the object and the image. So it is the same thing between these 2 points. So you can choose any point on your, in this case, our triangles to identify. So if you're moving from this point, all right, come in. So if we're moving from this point, you're moving 1, 2, 3, 4. So our mirror line would be halfway between that, which should be 2 units at the base. So it would be 1, 2, which would still be along the line y is equal to 0. So our answer is y is equal to 0. But giving another example, so you count the number of spaces between them, divide by 2. Basically, that is what you're doing, especially when it is on a graph. It is easier to identify the mirror line. So you're looking for that equidistance between both points, equal distance. So at that point, yeah, basically you're always dividing by 2, because remember, you're looking for the mirror line, because you're expecting that anywhere your mirror line is, both your object and your image is in the same distance away from it. So let's say this, my object is here. And my image is here. Where is my mirror line? What is the equation for my mirror line here? Y is equal to -5. So let's see. So we're moving 1, 2, 3, 4, 5, 6. So you're doing 6 divided by 2, which means that our mirror line is 3 units away from both our object and image. So it would be 1, 2, 3. So this is where my mirror line would be. So if you look where the mirror line is, it is 1, 2, 3 units away from the object and 1, 2, 3 units away from the image. At this point, y is equal to -5. So remember, Larissa, you're always writing it in equation. It is y is equal to -5. So the y values are negative down there. So you can pause it. Very good. So remember, you're taking the reading from the graph. So at this point, y is equal to a -5. It could, and it doesn't always have to be an equation where it is y, because if I'm doing this, if this is my object, and this is my image, what would be my mirror line? X is equal to 1. So if you look, it is 1, 2, 3, 4. There are 4 units apart, which means that my mirror line will be 2 units away from each, which would be right here. So 1, 2 to the object, 1, 2 to the image. So at this point, X is equal to 1. And that would have been my equation for where my mirror line is. I'm not sure if that is any clearer for those who didn't understand. Kyle, I'm using as a benchmark. Is this any clearer? Kyle? So I understand the Y1, but that X1 is not. So it is the same principle. It's just that now, if you realize, with all the other ones, they were above and beneath each other, but now they are side by side. So therefore, your mirror line can no longer be using an equation from the x-axis. Now you realize that this line, this now corresponds with our x-axis. So this mirror line is passing through our x-axis. So all along this line, x would be equal to 1. It's just that now they're no longer top and above each other, and that is where usually your equation would be y is equal to whatever value it is corresponding with. But now our points are side and side each other, and that is how now our equation becomes x is equal to, because the reading at which our mirror line is passing through, it is passing through our x-axis, and that is how we now have x is equal to 1. So it's the same principle, it's just that now there's a flip of it where it's not top and above each other, where our reading is coming from the y-axis, it is now coming from the x-axis. So I'm hoping that that is a bit clearer. Okay, very good. So that is it. So let me just get rid of some of these lines here. So that was our first answer at the point y is equal to 0. That is the equation. So that is our mirror line right there. So that is part 1, state the equation y is equal to 0. Part 2, yes, I'll send that coming closer to the end of the class. Or if someone can send it for me in the meantime, that would be good. Part 2 says, describe fully the transformation which maps triangle X onto triangle Z. So we're looking at mapping triangle X onto triangle Z. So one, can anybody tell me what transformation is taking place? First thing, what transformation is taking?
Rotation.
Rotation, very good. Look again, Kyle, that is not reflection. We're mapping X onto Z. This is X and this is Z. So rotation. So rotation is what is taking place. Will you use a clockwise or anti-clockwise? Because you can use both, but if you're using counterclockwise, so Tamia is going with counterclockwise, what is the degrees that you're attaching to this? what degree anti-clockwise or counterclockwise is this rotation happening? 90 degrees. Very good. So we have rotation and we have that it is anti-clockwise 90 degrees. Where is our center of rotation? Last piece of information that we need, and we are good. Last piece of information. Where is... No, we're doing June 2021 past paper. So we're at question 3, I think. No. So we looked at something similar. So I'm going to show you what how did we get 90? So based on where X is here, the rotation, so based on the direction in which don't worry, I'm going to show you. We're going to go there, but I was just hoping that more persons. So we're going, so this is how we got 90. So you're leaving here, going here. So your triangle was like this, and it underwent a rotation. So if you realize that everything, this point is now here, this point is now here, this point is now here. So it is an anti-clockwise movement. The center of rotation is 0. Thank you. I'm going to go there. And to help clear up the confusion, so let us label our triangle A, B, C. And that means this would be A, this would be B, and this would be C. Or A prime, sorry. So let's call it A prime, B prime, and C prime. So if you realize A prime, A here, the readings for A is 0, 2. The readings for A prime is -2, 0. For B, our reading is 6 from our x-axis and 2 from our y-axis, so 6, 2. Now look at B prime. B prime is -2, 6. C is 4 from our x-axis, 4 from our y. So our reading from C is 4, 4. From our C prime, it becomes -4, 4. Now, for those who have been in class last week and the week before and the week before, we looked exactly at what matrix is used here. Yes, CJ?
So, sorry, basically like the numbers flip.
Thank you. So that is exactly what we discussed. And so what we looked at last week and the week before, as you can realize from our X, Y values, in our image, what it becomes is our Y value now becomes our X value, but it is a negative Y, and our X value becomes our Y value, and it basically remains the same. You don't need to know the matrix. You don't need to, honestly, but it helps because we've looked at this concept last week. So basically, the matrix or the transformation that was used here is basically 0, -1, 1, 0. And we looked at this last week, and this matrix, it is attached to when there is a rotation through the center 90 degrees. So when there's an anti-clockwise rotation through the center 90 degrees. So all of this is theory that we looked at last week, and all of this is theory that your teacher more than likely went over with you. So in terms of must you know it, if you didn't know it, you could still look at what was happening and determine. So one, you could see that this is a rotation taking place. You could see that this was an anti-clockwise movement. Probably the only thing that you'd have struggled with is probably where is the rotation coming from, and probably by how much, but I'm sure you could also see that it is 90 degrees. But these are all the things that you need to state in your answer. So I'm hoping for those who are confused, you'd have seen. So what I'm saying is, for a value here, we had 0, 2. The value is basically flipped, and now we have -2, 0. So our x value becomes our y value, and our y value becomes our x value, but it now take on the negative sign. Same thing for b, it was 6, 2. The value is basically flipped, and now we have -2, 6. Same thing for 4 here. This flip isn't noticeable, but you'll realize that our x value becomes negative. So it now is -4, 4. So what we know is from that. So our answer is everything that we just discussed. So describe fully the transformation. So we can say it is a rotation, or it is a rotation of 90 degrees anti-clockwise through the center. Through the center, which is 0, 0. So it's -yx for the 90 degrees. So yes, so when the rotation takes place, using basically that transformation, it basically becomes -yx. So that is basically the digits, the values flip on your graph. So that is what is taking place here. By the way, you could find it as well, because if we connected the points, so like connecting from A to A and C to C and B to B, you could bisect each line. It's just that might take a bit longer. When you bisect each line, you'll see that all three would be passing through the center. And that also helps to confirm that the center of rotation is through the origin, which is 0, 0. So that is also another way of looking at it, but you'll still need to know that, hey, this is a rotation anti-clockwise 90 degrees. So that is basically our answer there. Part 3 now says, on the diagram, which is the same diagram that was just looking at, it says translate triangle y using the vector -7, 1 and label it as V. So we are translating triangle y using the vector so we're translating triangle y using the vector -7, 1. So let me just write that here. So we're transposing the vector, we're transposing triangle y, and we're using the vector -7, 1. You can use a formula, which is object plus the translation, or object plus transformation is equal to image, but you are using a graph paper. And I've been showing you since last week, when you're using the graph, there are easy ways to get exactly what your answer is. So let's say I'm labeling this A, B, C. And our translation vector here is -7, 1. Can anybody tell me, how can I use this on the graph to get where my A prime value would be? So using -7 and 1, how can I put this on A and get? And this is based on moving off in a direction. Will I go to the left? I've been doing it. All right, so go -7, go -7 to the left and 1 up. Very good. Very, very good. So I'm saying using this translation vector, instead of working it out using the formula of object plus transformation or translation vector is equal to image, you can use the graph and find it. So what this is telling us is that for each point, you're going to carry it 7 places to the left. That is what the negative sign means. You're going to the left. So 7 places to the left. And because the 1 is positive, you're going 1 up. Very good. So it is, no, this is not function. So this is 1, 2, 3, 4, 5, 6, 7, 1 place up. So this would be where A prime is. So this is A prime. You're doing the same thing for all the other values. So it is, for B, you're going 7 places across to the left. So it is 1, 2, 3, 4, 5, 6, 7, and then 1 place up. So this is where B prime is. And you're doing the same thing for C. So it is 7 places across, 1, 2, 3, 4, 5, 6, 7, 1 unit up. This is where C is. So this now is our C prime. And you connect all 3 points. And this is our newly found triangle. And they said we should label it as V. So all you're doing, you find where the points are and you label it V. And you'd have gotten your mark. So this is, you're using the graph. This is easy way of finding where exactly your triangle is being translated to. Any question from this?
So, sir. Sir, -7. It would have been.
You're going to the left on your graph.
Left across, and 1 that be going down.
No, 1 will be going up. Remember, the 1 is positive, so you're going
like
up.
Not, not in this case, sir. Like not in this case.
Or if it was, if it was negative. Does it
no, if like like if they never give it to solve this graph, sir. Like normally they don't give that on a graph, say transformation or something.
Oh, you're saying if they didn't give it on a graph?
Yeah.
Right, so if they didn't give it on a graph, all you're doing is for each point, you will be adding the translation vector to it. So for example, A, let's use one of the points. Let's say A here is 0. So if you look, A here is 0 from the x-axis, -2 from the y. So this is if you're using the formula. So if they didn't put it on a graph and you know the points, this is how you'd work it. So it would be 0, -2 plus the translation vector, which is -7, 1. So when you add these, it is 0 plus -7. That will give us -7 and -2 plus 1. That would give us a -1, right? CJ, so therefore A or A, this should be the values for A prime. You see that?
Yes, sir.
So now check back on our graph, which we got. You'll realize that we got the same answer. So this right here is -7, and this is -6 and -7 and -1 from our y-axis. So you realize it's the same values that you get. So whether you use the equation or you do it on your graph paper, it would be the same answer that you'll be getting. So if you're using the equation, all you're doing is each point which is considered the object plus the translation vector, and that will give you your image. Sir.
No, sir, when you ask it,
So, hold on, CJ. Hold on, CJ. So, Celine, if you realize the -7, it was given in the question. So they told us that that is our translation vector. So this is it. It says on the diagram, translate y using the vector -7, 1. So that is where we got the -7, 1 from. Yes, CJ, go ahead.
Yes, sir. Let me ask you, like, the same as give the formula for the mirror line.
Mm-hmm.
It are always equal to like x equal to number there or y equal to number there.
That's usually the case. Once it is on the graph, once they said find the equation, so it is usually x being equal to wherever that mirror line is, or y being equal to wherever the mirror line is. So that's halfway distance between both your object and your image. Yes, this is translation. So the question asks us to translate a triangle y to find.
So sir, so for instance, what's the mirror line be there, right? Which part the two there go up this one?
This?
Yeah, right. Another line there. Yes. What's the mirror line there, right?
As in this direction?
Yeah.
So this would have mean that your mirror line is x is equal to 2.
No, I mean like right now that's right above. Yeah,
as
right.
In this?
Go up. No man, go straight up.
See, I think I can mark on the screen. Show me exactly where you're speaking.
Let's see if we can mark.
But anyway, I'm not saying, but anywhere where the mirror line is, it is usually either cutting your x-axis or your y-axis, and that is what you'll use in determining what the equation is.
Right, sir.
All right, good. So we found part 3. So sorry to backtrack, but can you just please repeat how we would get the 90 above for each transformation? So I got the 90 in 2 ways. One, from looking at it based on the direction in which the diagram is going. So you can see this red arrow that I drew. So our x is here, and it's basically going in this direction. By the way, this would have been the same way. Anti-clockwise 90 degrees is the same as clockwise 270 degrees. Because remember, all of your degrees is making a complete, very good. So yes, clockwise 270. So you could either say it is anti-clockwise 90 degrees, or you could actually say it was clockwise 270 degrees. So any one that you choose, but also from observing how soon come to that, Janelle. From observing how this is, from theory, you know that when you have x, y being given and your points then flip, basically take us -y x, then that alone could tell us everything that is happening. That one, it is anti-clockwise 90 or clockwise 270. This is going through the center, which is our origin point 0, 0, and all of that good stuff. So from theory, you could also decide, but also from looking at our diagram, the first thing that you know is that one, it is a rotation. Based on the direction in which it is going, then we can see, yes, you can use a degree for each quadrant as well, and it would give you the same 90 degrees going from X to Z. Now going to general question, the vector that the question, we use it to find A, B, C. You can use it, and that's what I was showing you. You can use the vector to find where A, B, and C would fall, or you can use the vector to just count on your graph. So you can either work it using the equation method here that I was doing, but you see that whether you work the equation method or just use the translation vector to count on your graph. So whenever any of your unit is negative, it means that you're going to the left in terms of the x-axis, And if your y value was negative, it means that you're going down. If your x value is positive, you're going to the right. And if your y value is positive, you're going up, which in this case, our x value is negative. So we're going 7 units to the left, and our y value is positive. So we're going 1 value up. So that is what we use it to find what our A prime, B prime, and C prime values are in order to label the triangle V, which is what the question asks us to do. You could use the same translation vector in the equation format to work out. So you will then take B, and B is 6, negative 2. And if you add 6, negative 2 plus negative 7, 1, you'd still get the same value here, which is negative 1, negative 1. Yes, negative 1, negative 1. So either way that you choose to do it, you would arrive at the same answer. And now part 4, it says on the diagram, enlarge triangle X about the center which is 0, 0, and the scale factor 1/2, and label this W. Now if you remember last week we looked at this, we said when we look at enlargement doesn't only speak to, in mathematics, enlargement doesn't only speak to your object getting bigger. Enlargement based on what your scale factor is. How did we get this? The question gave us a scale factor. It says scale factor of 1/2. Yes, exactly. So based on what the scale factor is. So usually when your scale factor is a fraction, it means that your object is actually getting smaller. And someone said 2. I'm not sure exactly which one you're speaking of, Selena, but I can go back to it shortly. But in looking at this, because our scale factor is now 1/2, or scale factor is 1/2, it means that from looking at it, we know that our image would actually be smaller. Yes, Janelle?
Sir, are they always going to give us the scale factor in the question?
Yes, once they're asking you to enlarge your image, then usually they will give you the scale factor and tell you where the center of rotation is. So those 2 variables are usually given, where the center of rotation is and your scale factor. In this case, this one is pretty easy compared to previous years because the center of rotation is through the origin, which is 0, 0, and your scale factor is 1/2, which means that all you're required to do is to multiply each point on your object, which is, we are at enlarged triangle X. So all you're doing is multiplying each point on triangle X by 1/2. So for example, where we have 0 and 2, if we should multiply this by 1/2, what you'll get is 0, 1, correct? Everyone is with me? So if I should multiply, all right, yes, so very good, 0, 1. So therefore, my new point for A prime, did they say what we should label it as? Let me see. Okay, they say we should label it as W in the end. So if we should get, so we'll have 0, 1. So this should be, go over that please. Okay, so I'm saying, so the question said our center of rotation is 0, so that doesn't affect anything, but they tell us that our scale factor is 1/2. The scale factor is what you'll be multiplying each value here by, what your values on your graph is. So for example, we know that A is 0, 2, so you're multiplying both your x-axis and the y-axis by the scale factor. So let me go down and show you where we got that scale factor. It is in the question. It told us that our scale factor is 1/2. So, and no, your scale factor isn't always a fraction, it isn't always 1/2. Your scale factor can be 2. When your scale factors are numbers like 2 or 3, it means that your image will be larger than your object. In this case, our scale factor is 1/2. So you're multiplying both your x and y value here by a half. So it is 0 and 2. When you multiply this by a half, you'll get 0 and 1. And that is how I get 0 from my x-axis, 1 from my y-axis here. Let me use another color. Okay, let's use yellow. So that is how we get this here. So now our new point for our enlarged image is 0, 1. Follow me, Bibi. Come in. You get that right? So what I did was to multiply a half by 0 and 2 here. So 0 multiplied by a half will still give us 0. 2 multiplied by a half will give us 1. And that is how we get our first reading here for 0, 1. So 0, 1. That is our first reading. Following me? So if we should look at B, what would be the new coordinates for B? We have 6 and 2 from the original image, 3 and 1. So a half multiplied by 6, you will get 3, and 2 multiplied by a half, you'll get 1. So 3, 1. So this would be where our new B prime is. So our second point, 3, 1. So for C, we had 4, 4. So what would be our enlarged coordinates for C? Very good. 2, 2. So it would be 2 from our x-axis, 2 from our y. And this would be our new enlarged image. And yes, this is how it will look on your paper. So this is how it is in its small form, and you put the letter W in it. This is how graph papers looked last year. So from both your newly formed triangle V here with your newly formed triangle W here. So it was looking like students were working. But this is it. So your scale factor, remember when you're looking at enlargement in mathematics, doesn't mean that your image will always be larger than the object. It is dependent on what your scale factor is. In this case, our scale factor is a fraction, which is a half, which means that our image is half the size of what our object is. Our object was X, and we're using our scale factor of a half on this, so we expected our image to look smaller, and that is how we get triangle W there. And that is the end of that question. Stop recording.